So that brings us to this topic, which is tangents and normals, equations, finding equations of tangents and normals. So it's example 12.20, and they ask us to find the equation of the tangent to f of x equals x plus 1 over x at the point 1/2, comma 5/2. Okay, so if we want to find the tangent at that point, we're going to need the derivative. So the derivative, well, first of all, I'm going to rewrite f of x, just so you guys understand how I do the derivative. So f of x, we can rewrite as x plus x to the minus 1. It's easier to do the derivative this way. So then the derivative would be 1 minus x to the negative 2, or, which is the same, 1 minus 1 over x squared. So we need to find the slope at the point x equals 1/2. So the slope for the tangent line is going to equal, plugging in 1/2 into the derivative. So this would be 1 over, or 1 minus 1 over 1/2 squared. And this is just going to be 1 minus 4, which is negative 3. So this is the slope at that point. Okay. Now these equations are linear equations, and one of the easiest ways to write or find these linear equations is by using the point-slope formula. The point-slope formula for linear equations says that they're equal to y minus y1 equal to m times x minus x1. And all we have to do is plug in the slope and a y value and an x value of the coordinate at that point. So we can rewrite this as y minus 5/2 is equal to negative 3 times x minus 1/2. And then we can expand this. We're going to get that y equals minus 3x plus 3/2 plus 5/2. And notice that this equals y. Y is equal to negative 3x plus 8/2, right? Because this gives us 8/2, so this is 4. So that means that this is the equation of the tangent line of the graph at the point 1/2, 5/2. Now what does that mean? That means that if you have a line, let's suppose it looks a little bit like this, let's suppose. And then they want you to find the tangent at this point. And let's suppose that this point here is 1/2, comma 5/2. So what we're finding is, first of all, the slope. We find the slope, and then we plug in the point into the formula, and we get a linear equation that represents something like this, a tangent line at this point. Now notice that this is infinite, right? So we should have arrows here. Okay, so here we are on example 12.21, where they tell us, consider the function g of x equals x squared times x minus 1. A, find the 2 points on the graph of g at which the slope of the curve is 8. So for the slope of the curve, we need the derivative. But before we do that, I want to expand g of x to make it easier to find the derivative. So notice that x squared times x minus 1 is the same as x cubed minus x squared. And then the derivative of g of x is going to be 3x squared minus 2x. So they want us to find the points at which the slope is equal to 8. So that means that they want to find out where this equals 8. So this is a quadratic equation, as you can see. Now this is the same as saying 3x squared minus 2x minus 8 is equal to 0. And then if we factor this, we're going to get 3x plus 4 times x minus 2. So that means that the 2 points, or the 2 x coordinates at which the graph of g has a slope of 8, would be then negative 4/3 and 2. So that means that we still have to plug these in the original function, right? So g of negative 4/3 is going to give us some horrible number, negative 112 over 27. And then if we do g of 2, that's going to give us 4. So we found the 2 points. The 2 points would be negative 4/3, comma, negative 112/27, and 2, comma, 4. Okay, so that would be, those would be the 2 coordinates, or the 2 points on the graph at which the slope is equal to 8. So for part B, they want us to find the equations of the tangents at those 2 points. All right, so let's get rid of this. And let's start with B. So in order to find those equations, we need the slope, which we already know, the slope is 8, and we need the points, which we found, right? So one of the points was minus 4/3, comma, minus 112 over 27, and the other one was 2, comma, 4. So we need to use these 3 things in order to find the 2 equations. So let's find the first equation. So using the point slope formula, we're going to have that the first equation would be y minus y1, so that would be y minus 4/3, so y plus 4/3 is equal to 8 times x minus minus, so x plus, oh, I'm doing it backwards. Y is not 4/3, y is negative 112/27, so this is going to be 112 over 27, and then x plus 4/3. Okay, so if we expand this and rearrange it, we're going to get that y is equal to 8x plus 176/27. So this would be the first equation. And then to find the second equation, we do the same process, but we plug in 2 and 4. So it would be y minus 4 is equal to 8 times x minus 2. And then if we expand this, we're going to get that y is equal to 8x minus 12. Therefore, this and this are the 2 equations of the tangents to the curve at those 2 points. Okay, so another thing that they might ask you to do is what we see on this slide, which is to find a normal to a curve. Now, the normal is simply a different way of saying the perpendicular to the tangent. So notice that it goes through the same point, so we require the use of the same point. And then simply we need the fact of the slope being perpendicular. So if the slope of the tangent is m1 and the slope of the normal is m2, their multiplication should equal -1. So basically the process to find the normal is the same as the one to finding the tangent, but then we have to find the perpendicular slope. So that's precisely what they want us to do in example 12.22, to find the equation of the normal of a graph. Okay, at the point 1, comma, -1. So this is the function. Let's find the derivative. So dy dx would be equal to 4x minus 6. So what is the slope at x equals 1? It's going to be -2. But that's the slope of the tangent, and we need the slope of the normal. But remember that -2 times m2, the slope of the normal, has to equal -1. Therefore, the slope of the normal is 1/2. And with this information, we have enough to find the equation, because it's going to be in the form y minus 1, so y plus 1 equal to 1/2 times x minus 1. Expanding and rearranging, we're going to get that y is equal to 1/2 x minus 3/2. And this is the equation of the normal. All right, so here we are now on example 12.23, where they say, consider the parabola with the equation y equals 1/4 x squared. A, find the equations of the normals at the points -2, 1 and -4, 4. So let's start with that. First thing we need to do is to find the derivative, and the derivative, dy dx, is simply going to be 1/2 x. Okay, so that implies that at x equals -2, the slope of the tangent is going to be -1. Therefore, the slope of the normal is 1. And then at the other point, at x equals -4, the slope of the tangent would equal -2. Therefore, the slope of the normal is 1/2. And now with this information and the coordinates of their points, we're going to be able to find the equation. So in the first case, let's write y minus 1. Y minus 1 is equal to 1, which we don't write, times x minus 2, so x plus 2. And if we rearrange this, we're going to get that y is equal to x plus 3. So this will be our first normal. For the second case, we're going to have that y minus 4 is equal to 1/2 times x minus, so x plus 4. So then that means that y minus 4 is equal to 1/2 x plus 2. So y is going to be equal to 1/2 x plus 6. So these are the two equations. And with these two equations, we're going to solve part B. So let's erase this and let's work on part B. So let's recall then that the two equations we found were y equals x plus 3, so that's one of the normals, and the other one is y equals 1/2 x plus 6. So they're telling us, show that the point of intersection of these two normals lies on the parabola. Okay, so let's find the point of intersection. For this, let's equal x plus 3 to 1/2 x plus 6, and we're going to have that 1/2 x equals 3, so x equals 6. And if x equals 6, y has to equal 9. So the point of intersection is 6, 9. So in order to prove that this point lies on the parabola, we're going to have to plug in 6 into the parabola, and it has to give us 9. So remember that the equation of the parabola is y equals 1/4 x squared. And in this case, we need to see what 1/4 6 squared gives us. And notice that this is 1/4 36, which equals 9. Therefore, the intersection of the two normals lies on the parabola.